All right, this is the Geometry Unit 4, Lesson 4 video over congruence of right triangles. So we're taking some of the concepts from the previous lesson and we're saying, well, what does it have to do with right triangles? Is there some unique characteristic that right triangles have that maybe play out differently when it comes to congruence? But the first thing that is addressed in the lesson is the use of the Pythagorean theorem. And so I want to just really briefly go over one thing and then let you know that there is a video that is labeled as part 1 of lesson 4. This is the part 2 video. Make sure you go back and watch that lesson over the Pythagorean theorem. But what you need to know before you go and do that is just simply that the legs of a right triangle, which are the two that make up the right angle, are known as A and B when you do the Pythagorean theorem, and the hypotenuse is known as C. Hopefully you're pretty familiar. Pythagorean theorem is something you learn throughout your math career, even before you get to high school geometry. So that should be something that's familiar to you. So go watch the video on Pythagorean theorem. It is labeled as the Geometry Unit 4, Lesson 4, Part 1 video. This is the Part 2 video. So beyond that, we have 4 ways to prove that right triangles are congruent. I'm not going to go into a detailed explanation of why we can't do it with just one additional part, but for you can go watch the last video for kind of an explanation for how some of that works. But I'm just going to tell you, so for right triangles, we have a unique set of congruence theorems to prove that right triangles are congruent. So I'm going to jump over to Google Keep, and I'm going to get us a drawing so we can look at these. So these are going to be what we call right triangle congruence. And I'll just say this information is also on the triangle congruence theorems worksheet or notes page that I have put on the Google Classroom. It's the bottom half of the page. There are 4 congruence theorems for right triangles, and they are as follows. So the idea here is that with a right triangle, it's easier in some ways to prove the triangles are congruent because you already have one part that is the same always, and that is the right angle. So in all right triangles, we're assuming that we have that first part already done. So that would be one angle. And what's nice is that because it's a right angle, it kind of makes it easier for us to prove that triangles are congruent. So the first triangle congruence theorem for right triangles is if I can prove that the two legs of my triangle are congruent, then I can prove that these triangles are congruent, and that is called leg-leg or LL congruence. So again, these are legs because the right angle is located here. So the legs always make up the right triangle, or the right angle rather. This is the right angle. On the screen you see that here. This is the right angle, so then those are the legs. The hypotenuse is the other side. It's always the longest side, and we'll get to that in a second. So that's one. Next, what if I have a leg and the hypotenuse, for instance? Well, if we have that, again, our right angle is right here. We have one of the legs, and we have we have the hypotenuse. Make that a little bigger to make it look right. There we go. And this would be considered HL congruence because we're looking at the hypotenuse and one of the legs. So that's the second type of triangle congruence. Additionally, we could have leg angle. Let's say I have these 2 right triangles. A little bigger there. Have these 2 right triangles. We have a right angle here and a right angle here. And this angle is congruent to this angle, and this hypotenuse here is congruent to the hypotenuse there. So this would be HA. It's the hypotenuse and one of the angles. It does not matter which angle it is. It's not like the SAS or the ASA where it has to be in a particular location. It doesn't really matter. So HA. And since we've done almost every combination, the last combination should be pretty obvious what it's going to be. And it is if I have a leg and an angle. So this would be LA. It's when you have a pair of legs and a pair of angles that are congruent. Again, remember how you determine what a leg is and what a hypotenuse is, so you make sure you're getting those right. So all of that is summarized on the triangle congruence worksheet here. Looking at the lesson, I'm going to kind of jump down. You have vocabulary to begin. Questions 1 and 2. 3 and 4 are Pythagorean theorem problems. So make sure you look at the part 1 video for how to complete those. You're going to need to draw your own diagrams here of what these triangles look like. Like it says one leg has a measure of 7 centimeters and the other leg has a measure of 9 centimeters. So I'll just get you started and tell you you're looking for C, the hypotenuse. I'll let you do the other one on your own completely, but that would kind of get you started for what you're kind of expected to do with numbers 3 and 4. Number 5, all of this is explained in the lesson up here. It tells you which one goes with each of the previous lesson's congruence theorems. So that's more or less vocabulary. So read these paragraphs around each of these other theorems so you know which of the postulates goes with the postulates from the previous lesson. So you're going to be choosing either SAS, AAS, or ASA. These other answers are not good options. So you'll need those 3 answers for each one of these, which one corresponds with the right triangle theorems. And that's all in the lesson itself. Then I think all we have left is proofs. So let me go through these with you. All right. Here it says that we have triangle ABO and triangle DEO, and they are right triangles. We see that right here and right here. We also know that AB is congruent to DE. That's here and here. And we know that they are also parallel. So we already have a leg. So we already know we're either going to have LL, HL, or LA. So we're already kind of locked in there. We know we're not going to use HA because AB and DE are legs of that triangle. So looking at our proof, they have our givens. Then they say angle B is congruent to angle E. Okay, well, that's because those are right triangles. All right angles are congruent. So right angles are always congruent to other right angles. That's how we know it's all right angles are congruent. Then we have angle A is congruent to angle D. The question is, how do we prove that? Well, this is going to go back to the fact that we have parallel lines, and those are alternate interior angles. They give us a hint right here. AD is a transversal cutting parallel line segments. So that's going to be alternate interior angles. And then lastly, we get to prove the triangles are congruent, and we do so by saying, well, we have 2 angles. Or we have a pair of angles and a pair of sides, and that is, let's see, that's a leg and an angle. And so they don't give us that, which is a little bit weird, but I'm assuming they're wanting us to choose ASA. Now we know it's actually also the same as LA, but for the purposes of this, we're going to use ASA congruence because we can see up here in our diagram, we have an angle, a side, and an angle there. And that's where we get ASA from. All right, so make sure you get those answers for the proof down. This is a kind of word problem, but it's more or less a triangle congruence question as well. Jake, Edmund, Kim, and Maria were in Washington, D.C. attending a rally. One of the rally events was a walking race that began at a point near the center of Lincoln Park. That's point C. The red group was to walk west along East Capitol Street Northeast for 420 meters. Okay, let's find where that is. That's going to be right here, 420. And then north on 8th Street Southeast for 200 meters. Then southeast on Massachusetts Avenue. That's going to be this right here. That's the hypotenuse of that triangle because this is a right angle. So we know we could use the Pythagorean theorem to find that distance right there. The other team goes the same thing. They go 420 and then 200. It says here that Jake contends that these two triangles are congruent. How can we know that? Well, we know that these are right triangles. And then they're going to take us through a proof. Well, they give us all this information here in number 1. We're given all of this. That's all coming from here. That's given. Then AC is congruent to CD, and AB is congruent to DE. So that's the fact that these sides are congruent. That's this side is congruent to this side is congruent to this side. That's all because of the fact that those are congruent. They're the same length. And then they say that these segments are congruent. That's the definition of congruence. That's going to be answer choice D. And then they prove that the triangles are congruent because of one of our theorems. Well, those are both legs. So we should be able to see that it's going to be leg congruence. Looking at these, I see I have the two legs of my triangle. And so it's going to be leg congruence for the last answer selection, which is answer choice B. All right. More of the same. Now they want to know how long the distance is along Massachusetts Avenue. That's this. That's the C. That's the hypotenuse. So you use the Pythagorean theorem to solve for that distance. Sorry about that. Okay, so that's how you do number 8. No need to do anything additional, but you're just going to use the Pythagorean theorem. They even tell you. And then we have one quick proof here at the end. We have triangle ABC and triangle CDA are right triangles, and AD is congruent to CB. So we have right angle here, right angle here. We have these two are congruent. And then they want to use the reflexive property. If I'm using the reflexive property, I should know instantaneously that I'm looking for something where it's the same. And that's why we're going to use answer choice C for that. Because we know that AC is congruent to AC. That's right here. And then we can prove the triangle is congruent because we have the hypotenuse, which is AC. That's the hypotenuse. And we have a leg. And so that's how we know it's going to be answer choice A. All right, so that's it for this lesson. Remember, you need to mainly focus on the Pythagorean theorem, as well as knowing those triangle congruence theorems and what they look like generally. Please make sure you also watch the video for part 1 before you do those Pythagorean theorem problems.